Expecting you went through that dull opening, you would show up at one more universe. There is, as of now, a relationship between quantum processing and dim openings. In this instructive video, we explore a vital and startling discovery made by the James Webb Space Telescope inside a dim opening, explained by, in all honesty, Bill Nye the Science Guy. A dim opening is a star so tremendous that, without a doubt, even light can't escape from it because of its huge gravity. The mysteries of dim openings have puzzled specialists for a long time. Anyway, as of now, by virtue of surprising limits, we've seen something truly stunning. The extremely large dull opening consumes what could be contrasted with one Earth every day. The faltering and persuasive first image of a dim opening in space. Get ready yourself as we dive into the unbelievable nuances of this endless exposure and what it could mean for how we could decipher the universe. Stars, around the completion of their life, much more great and enormous than the Sun, run out of fuel and begin to break down as gravity squashes them. Dim openings are fascinating. To remember, it was, as a matter of fact, a test to search for the beginning one. Regardless of the way that Einstein's theory of relativity anticipated they were normal, dissimilar to stars, dim openings radiate no light by their own doing. Their size and turn are the only quantifiable properties we have. Visual verification of dim openings attests to their existence. Distance has only recently opened up, and, at any rate, authoritative affirmation of dim openings was lacking for a long time. The first dim opening, Sagittarius X1, was seen in 1964, but it required over 30 years for experts like Stephen Hawking and Kip Thorne to agree on whether Sagittarius X1 was, for sure, a dim opening. Hawking and other observable figures in dim research made sure of their open examination presence, but they were cautious about the shortfall of definitive revelations. Hawking and Thorne were almost 100% sure that Sagittarius X1 was a dim opening in 1975 when the wager was first cast. By 1988, they were 95% sure. Still, they held on until 1990 to respect verification when more observations gave satisfactory affirmation. The beginning discovery of Sagittarius X1 was made using 2 Geiger counters sent into space on a suborbital rocket, detecting a signal pinpointed to a system 7,200 light-years away. The system highlighted a blue supergiant star circling another colossal object emitting strong X-rays, which would make sense if it were a dim opening. Much examination has focused on Sagittarius X1 since its discovery, revealing that it is multiple times the mass of the Sun, making it the largest known stellar mass dim opening found without gravitational waves. This discovery challenges long-held notions about dim opening development and the mass loss experienced by stars over their lifetimes. Sagittarius X1 breaks records in more ways than one. Its remarkable mass and the fastest spin speed of any dim opening observed up until now, moving toward the speed of light, oppose the accepted pattern of dim opening development. Although definitive evidence of dim openings has only recently been found, it is increasingly obvious that they are scattered throughout the universe. In any event, expecting analysts ultimately disentangle all the mysteries of Sagittarius X1, the first of its kind, endless others still hold a vast number of surprises. Under 2,000 light-years from Earth, specialists have found a dormant giant, the Milky Way's largest stellar mass dim opening, Gaia BH3, with a mass several times greater than that of our Sun. In spite of being the second closest known dim opening to Earth, Gaia BH3 remained inconspicuous until recently. Gaia BH3 was found accidentally while scientists from the European Space Organization inspected information from the Gaia mission, which maps our galaxy in 3D. The discovery of this dormant dim opening, which isn't actively siphoning energy and material from a companion star, was a complete surprise. Normally, stellar mass dim openings in our Milky Way have a mass several times that of the Sun, with Sagittarius X1 holding the record at 15 times the Sun's mass. However, Gaia BH3, with a mass of 33 solar masses, is still small compared to all dim openings. For example, the central supermassive dim opening in our galaxy, Sagittarius A*, is 4 million times greater than the Sun. Gaia BH3 is the second nearest dim opening to Earth, behind only Gaia BH1, which is 1,500 light-years away and has several times the mass of the Sun. Cosmologists now have more evidence to understand how stellar mass dim openings form. Dim openings from the end of massive stars with lower concentrations of heavy metals are believed to be the source of these enormous stellar mass dim openings. These metal-poor stars, made primarily of hydrogen and helium, are thought to experience slower mass loss, leaving more material available to form large dim openings when they die. Using the James Webb Space Telescope, JWST, specialists have found an incredibly red, very massive dim opening existing in the early universe's shadow. As the universe expanded, the very massive dim opening took on a reddish hue. 700 million years after the Big Bang, the light traveling toward us is redshifted, suggesting a thick layer of gas and dust surrounding the dim opening. Lucas P. Finnell and A.V. Curve of the Beanan College of the NAS Cosmology Group determined the dim opening's mass using JWST data, finding it to be around 40 times the Sun's mass. This discovery stands out from the universe it inhabits, showing that the very massive dim opening is quickly consuming the surrounding dust and gas. Located about 12.9 billion light-years from Earth, this quasar was initially recognized by its red appearance. Quasars are made when a lot of material surrounds very massive dim openings, forming a disk of gas and dust that feeds the dim opening. The massive gravitational impact of the dim opening disrupts this matter, creating extreme temperatures and making it shine. The light produced by quasars can be so brilliant that it eclipses all the stars in their surrounding galaxy. The JWST identified this very large dim opening as a small point due to the massive amount of radiation it was emitting. The object was initially identified as a strange star-forming galaxy. In light of color analysis supporting the theory of very massive dim openings, its small size and very massive nature stood out from other quasars observed in the early universe. This discovery was made possible by gravitational lensing, a phenomenon predicted by Einstein in 1915. Einstein's theory of general relativity suggests that objects of mass bend the fabric of spacetime, which combines into a single entity called spacetime. This curve creates gravity, and the larger the object, the more intense the curvature. The shape of spacetime also influences the light emitted by stars, bending it as it passes close to massive objects. This phenomenon, known as gravitational lensing, allows us to see distant objects that would otherwise be invisible. The JWST used this effect, supported by a galaxy group called SMX J7233-7327, to amplify the brightness of distant galaxies and reveal the red quasar. This new information adds to the growing body of evidence that the early universe was populated with exceptionally large dim openings, which can be millions or even billions of times heavier than the Sun.